Hey, welcome back everybody. In this video we're going to talk about time series versus extendable time series class objects in R. So being a time series econometrician, I deal a lot with time series data within the R environment, and I get asked many times from students about the difference between TS versus XTS class objects. Time series class objects, or TS objects, are designed to kind of provide some additional information within a vector of data, or even multiple vectors of data that's corresponding to a time domain or a time frequency. The XTS class object is kind of meant to kind of explode that a little bit and to provide some additional functionality to time series class objects. Now, it's sometimes hard to kind of talk about examples between XTS versus TS class objects, because sometimes you'll have an XTS object that you can take to time series, but sometimes some of the features that you need with an XTS class object you cannot take to time series. So I'm going to work through an example that will hopefully kind of highlight this a little bit better to kind of hopefully clear up some of this confusion. So we're going to use a library. If you don't have this library, you're going to want to install it using the install.packages function. But we're going to use the library quantmod. In quantmod, when you load this, it's actually going to load a handful of different packages as dependencies. It's going to load zoo, and it's going to load XTS, and if you don't have those, then of course it'll download them when you download the package. And we're going to pull some data from this. Now, the quantmod package is designed to kind of pull financial time series data from various sources here. In this case, we're going to pull the TED rate, and we're going to set the source of this query to come from the Federal Reserve Economic Database, or the FRED. So this is actually just going to go and use kind of a blanket API key that's built into the quantmod package, and it's going to pull the TED rate data from the FRED and download that as an XTS class object. And sure enough, in the global environment, we'll see XTS object and the start date. Now, if we want to kind of examine this a little bit further, we can use the head function, and we can put in TED rate, and we can see, okay, this starts in 1986, January, but in the first date of this, the very first observation is going to be January 2nd. And then we'll see January 3rd, but then we're missing January 4th, January 5th. This is a function of a lot of what we see within financial time series data. So we have an example here where we have clearly a data point that's happening at a daily frequency, but we don't have an observation for every single day. Rather, we have just only the trading days available here. And if we actually click on this TED rate data in the global environment and view this, we'll actually see one of the unique things that the XTS package does when it actually formats XTS class data. So here we can see kind of a row label, if you will, for every single observation. Now, another thing that I want to kind of point out here is you'll see within 1986, January 20th, you'll see an NA there. Sometimes you'll have NAs in this data, and that's going to come up when we start to play with this data. Now, if we wanted to take this XTS class data and bring this into a TS class, or a time series class object, which is kind of native to base R, we're going to have to change this. We're going to have to aggregate this and go up one degree of aggregation, if you will. So we might take this daily data and aggregate to the monthly frequency. So in order for us to do that, we'll go back to our script file, and we're going to create a new object, and we'll just call that TED month. And inside that, we're going to use the to.monthly function that resides in the XTS package. And here we're going to put in here, we want the TED rate data. And this function is used to aggregate data, and it'll take basically every observation within each given month, and it's going to average it together. Now, this function is often used for financial time series to create what are referred to as open, high, lows, close environments. And in this case, we're going to set that equal to false. But what that does is it would say, okay, well, what is the open? In this case, it'd be the first observation in January. And what's the high? It would be the highest point, and the low would be the lowest point, and the close would be at the end of January. If you don't tell it to do that, then it's going to produce a matrix, if you will, of data that has multiple different vectors corresponding to the open, high, and the low, and the close. In this case, we don't want that. We just want the one vector that is the average of every one of these TED rate, interest rates, and we're going to put this into just one single vector. Now we want to use the additionally the index at argument here that basically says how do we want to aggregate this, and we want to aggregate this to months. So we can run that command, and we're going to get a warning message. It's going to say, hey, wait a second, we have some missing values in here because we had some NAs that I recently pointed out. Now, if we use the head function again here for the TED month data, we'll see that now we have an observation for every single month. We'll see that the kind of timestamp, if you will, corresponds to the last observation, or the last daily observation within each given month, but it is the average of every single one of those rates. Great. Now from here we could actually take this and put this into a time series class object, because this is basically, now we have an observation for every single month here. And so with this in mind, we can use then the basic time series or TS class object. In order to declare this as a TS object, we'll create a new object, TED.TS, and in this case we'll put in the TED month, monthly aggregated data that we have. We have to declare a start for our time series, and here we're going to create a vector starting with the year, in this case 1986, and then the first observation being corresponding to month 1. Now, it doesn't necessarily know that this is monthly data until you add the frequency argument here, and we have monthly data now, so we're going to put 12 here. So if you had annual data, you'd put 1, quarterly data, you'd put 4, monthly data, you'd put 12. You get the idea. So great, so we can now execute that line, and then we'll see, okay, now we have a time series class object showing up down here for TED.TS. And so that's going to be slightly different than what we have for the XTS object. Here, if we just printed the head of TED.TS, we'll see, okay, we just have these 4 values. If we printed the full time series, okay, it's going to print a whole bunch of stuff, but you'll see now we have some slightly different identifiers for the actual data. We still see the monthly kind of labels, if you will. We'll still see the yearly labels, but this kind of behaves slightly differently than the XTS version of this. Now, one thing that kind of might help to highlight the difference between the time series class object versus the XTS class object is how this time series class object subdivides the time dimension of this. So I'm going to add an additional command down here to kind of highlight this. We're going to use the index function. And within the index function, I'm just going to put the actual time series class. And so this head function is, of course, going to print just the first few observations of the index for TED.TS. And here you kind of have a sense of what the time series dimension represents. So we have 1986 as an actual integer, not as a date object in and of itself. So we're saying, okay, we're going to start with year 1986. We've subdivided this by month at the frequency of 12. And so it's subdividing 1986 to 1987 by 12 and putting that as a decimal point. So when you plot the TED rate as a time series object, the x-axis for this is actually plotting along the numeric vector of 1985 all the way to the end of your data based on a subdivided integer along the frequency that we previously have defined, in this case frequency equal to 12. That's fundamentally different than when we have an XTS object where the actual date itself is actually shown as the actual x or independent variable, if you will. So if we saw this from an XTS object, and there's actually a whole different kind of graphing or plotting library for this. We'll put in just the TED month to kind of give us the exact same data here. And when we do that, of course, we have a slightly different graphing scheme, if you will. But in this case, this x-axis here, it is not plotting that at all, because if we did kind of something equivalent to here for the monthly data for the XTS object, we'd see head, index, TED month. We get an actual date class object that's printing there. So it's actually printing the date rather than some subdivided, evenly subdivided integer that represents the month or the year or whatever it is. So this is some of the kind of unique features of time series versus XTS data. Not all XTS data can go neatly into a TS object. Anything that's in the TS class object can go into the XTS class object. XTS has a little bit of a learning curve, but once you kind of get familiar with it, it's actually far more powerful than just the standard TS class objects. And so I try to push my students into the XTS class objects whenever I can. Anyway, hopefully this video was helpful for you. Please leave any questions or comments that you have down below, and thank you guys very much. Talk to you later.